Hi, my name is Radhika. Welcome to my additional mathematics classroom. Today we will do this paper, 2021 May-June paper 13.
Okay, let's start with the first question. Find the possible values of the constant k such that the equation kx square plus 4kx plus 3k plus 1 equal to 0 has two different real roots. Okay, so we have to show that this equation has two different roots. Now, as we can see from here, this is a quadratic equation of the form ax square plus bx plus c, where this is ax square, this term is bx, and this terms together is c equal to 0. Now, a quadratic equation can have three types of roots: two different and real roots, same real roots, and the third case imaginary roots. So who will decide that? It is b square minus 4ac. This expression decides what kind of the roots that a quadratic equation has. So this b square minus ac 4ac is called the determinant because it determines the nature of the roots. Where did we get it? We got it from the formula to find the roots. Remember, we have the formula for finding the x value or the root of the equation as this one. So it is this term that defines what kind of roots. So if b square minus 4ac is greater than 0, that means we have a proper square root, because square root is defined for only positive numbers. So if it is greater than 0, that means it's a positive number. There are two distinct real roots. So the first root is minus b plus this square root value divided by 2a. The second root will be minus b minus the value of this square root divided by 2a. So when b square minus 4ac is greater than 0, the roots are real and different, two different roots. Now this is the first case. Second case is when b square minus 4ac is exactly 0. So this whole term goes to 0. So we find that the square root, the value of x is just minus b by 2a, because this whole term is 0. So this plus or minus has no significance. So the root value is minus b by 2a. Does it mean we have just one root? No. We still have two roots, but we say it is same two roots. So they're real and same roots. And the third case is, as you can guess, it is b square minus 4ac is less than 0. So when this term is less than 0, say negative number, minus 10. What is the square root of negative 10? Not defined, right? So whenever there is a square root of a negative number is there, we call such numbers as imaginary numbers. So we say when this third case occurs, the roots are imaginary. So in this question we have to show that this equation has two different real roots, meaning that we have to show that the b square minus 4ac is greater than 0. Alright, let's start by identifying a, b and c first. So a is the coefficient of x square term, is k. b is the coefficient of x term, which is 4k. And c is the constant, which is 3k plus 1. So b square minus 4ac is equal to 4k whole square minus 4ac. So it is given that it is greater than 0. So this simplifies to 16k square minus 4k into 3k. We have 12k square minus and plus minus 4k into 1 is 4k greater than 0. 16k square minus 12k square, we get 4k square minus 4k greater than 0. So we divide by 4 on both sides, we get k square minus k greater than 0. Now at this point you may be thinking, why don't we divide by k and get rid of 1k also? So you may be thinking like this, divide by k, so we get k minus 1 greater than 0. Now this is a wrong step, we must not be doing. Don't do this, because if you do this we will lose one of the roots here. We will get only one value for k, which is wrong. So you can divide by a number, but don't divide by k. So we factorize the left side, k is common, k minus 1 greater than 0. Alright, so this is the inequality we have reached at. Now how do we find the value of k which satisfies this inequality? This is the inequality we have reached at. So the previous step was k square minus k must be greater than 0. Now let us say k square minus k is equal to 0, and let us plot the graph. So as you can see, it's a quadratic graph. The coefficient of k square is plus, so we get the graph concave up. And what are the roots of this equation? From here we find that if we equate this to 0, we get k equal to 0 or k equal to 1, right? So on this x-axis it is k, y-axis is y. So if it is equal to 0, the roots would have been k equal to 0 and k equal to 1. So these are the points, which is 0, and this is the point where k is equal to 1. So the roots are nothing but the place where the graph is cutting the x-axis. In this case it is k-axis. Now what is the condition we have? The condition we got is k into k minus 1 must be greater than 0. That means this graph, this entire thing is represented by this graph. So the graph is greater than 0. That means you can see here between the two roots, the graph is below 0. The value of y is all negative. The value of y is positive here and it is positive here. So what are the values of k? For this condition to be satisfied, k must be less than 0, so that we cover this part, and k is greater than 1, so we cover this part. So between 0 and 1, the value of y, or the value of the graph, or the value of this expression k into k minus 1 is less than 0. At exactly k equal to 0, k equal to 1, the value of the graph is equal to 0. But for this condition, the value of the graph, that means the value of y, is greater than 0. So the answer for this question is k less than 0 and k greater than 1. Right? Going to question number 2a. Find d by dx of x square into e power 3x. As you can see, we have two different terms in x which are multiplied to each other. So we have to apply the product rule. What is the product rule? D by dx of uv. How do we do this? You keep u first, differentiate v with respect to x, plus keep v as it is, differentiate u with respect to x. Okay, so let us identify our u to be x square and v to be e power 3x. So d by dx of x square into e power 3x is equal to u, that is x square d by dx of e power 3x, plus keep v as it is, e power 3x multiplied by d by dx of x square. So this is x square multiplied by, what is the differentiation of e power ax? It is same, exactly same function, which is e power 3x, exactly same, multiplied by, we have to differentiate this 3x. So differentiation of 3x is 3, plus e power 3x into differentiation of x square is 2x. What is differentiation of x power n? It is n, multiplied by x power n minus 1. That is, you write this index first, then write x, reduce this index by 1 and write here. So 2 minus 1 is 1. So keeping it in the most simplified form, we can see that e power 3x is a common factor. This remains 3x square from the first term plus 2x from the second term. So this is the answer for 2a. Let us start bi. Find d by dx of 3x square plus 4 whole power 1 over 3. Apply the formula d by dx of ax plus b whole power n. So just like x power n, we will do this as is like this. First write the index, which is n, then write the bracket whole ax plus b, reduce the power n by 1, then differentiate what is inside the bracket. Bracket open, differentiation of ax gives me a plus differentiation of b, which is a constant, gives me 0. So using this identity, we will differentiate the expression here. So we will bring the index down, 1 over 3, open bracket, 3x square plus 4, write everything as it is, reduce the power by 1, so do a minus 1, open the second bracket, differentiate the terms inside. So 3 into x square differentiation is 2x plus differentiation of a constant 4 is 0. So this simplifies to 1 over 3, 3x square plus 4, 1 over 3 minus 1 is minus 2 over 3 into 6x. So we can simplify this, 3 1 times, 3 2 times. So this simplifies to 2x multiplied by 3x square plus 4 power minus 2 over 3. So you can leave it at this stage, or you can write it as the positive power of the bracket. Now to BII, we have to integrate from 0 to 2 x into 3x square plus 4 power minus 2 over 3 dx. So hence find, we have a hence there, which means we have to use the results of the previous parts of the question. So from the previous part, we found that d by dx of 3x square plus 4 whole power 1 over 3 was equal to 2x into 3x square plus 4 power minus 2 over 3. So we found this here. Now look the question carefully. We have to integrate this one, which looks exactly like this except for the 2 there. So if we forget 2 for a moment, it is x, 3x square plus 4 power minus 2 over 3. So that means we are integrating both sides. If we integrate, put an integrate sign, it looks exactly like this question. But what happens to the left side? There is integration, there is differentiation. As you know, they are reverse operations of each other, they get cancelled. So that means integration of this right hand side is this bracket. Okay, so from here we see that integration of 2x into 3x square plus 4 minus 2 over 3 dx is nothing but 3x square plus 4 power 1 over 3. So, but this doesn't have a 2 there, so we can remove that 2 and write integration of x into 3x square plus 4 power minus 2 over 3 dx is 3x square plus 4 power 1 over 3 whole divided by 2, because it's a constant, doesn't make any difference for this integration. Alright, so to answer this question, we will use this right hand side. So this is equal to 3x square plus 4. So we are using this result here, 1 over 3 whole divided by 2 with the limits of integration from 0 to 2. Alright, so let us keep the half outside, that is this 2. Let us apply the integral constants now. So 2 square, 3 into 2 square plus 4 power 1 over 3 minus 3 into 0 square plus 4 power 1 over 3. This simplifies to 4 plus 4 multiplied by 3, 12 plus 4 is 16. 16 power 1 over 3 minus 3 into 0 square is 0. 0 plus 4 is 4 power 1 over 3. So, if we use the calculator to find the third root of 16, find the third root of 4, subtract and divide by 2, we find that the bracket simplifies to 0.932. So, you divide it by 2, we get the final answer 0.466. So, this is the answer for 2BII. Okay, so we are starting with question number 3. Solve the equation cosec square theta plus 2 cot square theta is equal to 2 cot theta plus 9, where theta is between minus pi by 2 to plus pi by 2. So let's recall the identity 1 plus cot square theta is equal to cosec square theta. So this is the trigonometric identity that we will be using here. So cosec square theta will be replaced by 1 plus cot square theta plus 2 cot square theta is equal to 2 cot theta plus 9. Now we have our entire equation in cot theta. So we will simplify this. Cot square theta plus 2 cot square theta, we get 3 cot square theta. Bring this 2 cot theta to the left side, it becomes minus 2 cot theta. There is 1 here, there is minus 9. So that gives us minus 8 with the right hand side 0. Now this is a quadratic equation in cot theta. So applying the formula, cot theta is equal to minus b plus or minus. So how do we find this roots of a quadratic equation? This is the formula, minus b plus or minus b square minus 4ac divided by 2a. So what are our a, b and c here? A is equal to the coefficient of x square, in this case cot square is 3. B is the coefficient of x, which is cot theta minus 2, and c is the constant minus 8. So let us substitute minus b plus or minus square root of b square minus 2 square minus 4ac divided by 2 into a. So this value comes to be, with the plus value we get the value 2, and with the minus value we get the value minus 4 over 3. So from here we will proceed. As tan theta, what is cos theta? Theta is 1 over tan theta is equal to 2, or 1 over tan theta is equal to minus 4 over 3. So from here we find that tan theta is equal to 1 over 2, or tan theta is equal to minus 3 over 4. This gives us theta equal to 0.464, and here theta is equal to minus 0.644. So these are the two values which is the answer for question number 3. Question number 4a. Find the first 3 non-zero terms in the expansion of 2 minus x square divided by 4 to the power 6 in ascending powers of x. Simplify each term. So we have to have a knowledge of binomial expansion. So how do we do? if we have a plus xb whole power n, how do we expand this? Simple, start with the index n c 0. So always this will be 0. Start with the index n c 0 multiplied with, start with the first term a raised to the power n multiplied by the second term raised to the power 0, whatever numbers you see here, 0. So you have to be very careful when you write the first term. So next of the terms will follow easily. How do we write that? This n remains same. C, you increment this number, it becomes 1 multiplied by a power, you decrement this number by 1. So it becomes n minus 1. The second term, increment this by 1. So every time the first term power will keep decrementing by 1, the second term power keeps incrementing by 1, and manage this NC0, NC1, NC2 in a regular fashion. So next term is NC2. Now you should be able to guess a power n minus 1 minus 1, which is n minus 2. XB power 1, we will increase, becomes 2. So if you go on doing this, the last term will be NCN into a power will reduce and becomes 0, and the second term XB power will increase and becomes until n. So that is going to be our last term. Alright, so pause this video, be able to write this on your own and then proceed. Okay, so now we are going to binomially expand this one. 6c0 multiplied with the first term power 6, the second term along with the sign power 0, plus 6c1, first term we reduce the index, second term we increase the index, plus 6c2 2 power 4 minus x square power by 4 power 2. So we are interested in the first 3 terms only. So we will stop it here. There are many more terms. Okay, so we are not going to write all of them. Alright. So 6c0 into 2 power 6 gives us 64. And this bracket power 0 is 1. So 64 multiplied by 1 is 64, plus 6c1 is 6, 2 power 5 is 32, minus x square by 4, plus 6c2 is 15 into 2 power 4 is 16, multiplied by this negative bracket, when you negative sign, when you square it, it will become positive. So this becomes x power 4 divided by 16. So we will simplify this further. So here plus and minus, we get a minus. So 6 multiplied by 32 divided by 4 gives us 48x square, plus this 16 cancels out with this 16, we get 15x power 4. So it is better to show this because there are many more terms. So this is the answer for 4a. Now on to 4b. Hence find the term independent of x in the expansion of 2 brackets. Now the first bracket we have already expanded. We will expand the second bracket and then we will see what is the term that is independent of x. Okay, so let us expand the second bracket. 3 minus 1 over x square power 2. So as we learned already, we start with the index 2c0, 3 power 2 into minus 1 over x square power 0, plus 2c1, 3 power 1 minus 1 over x square power 1, plus 2c2, 3 power 0 minus 1 over x square power 2. So there are only 3 terms here. Okay, so 2c0 into 3 square is 9, and this bracket power 0 is 1, so 9 into 1 is 9, plus 2c1 is 2 multiplied by 3 multiplied by 1 over x square, plus 2c2 is 1, 3 power 0 is 1 multiplied by the minus and square gives us a positive number, so it will be 1 over x power 4. So this simplifies to 1 plus and minus here gives us minus 6 over x square plus 1 over x power 4. So this is the expansion of the second bracket. Now let us recall the expansion of the first bracket. It was like this: 64 minus 48x square plus 15x power 4 and so on. So now we have to find a term which is independent of x. That means a term which is a constant when we multiply the two brackets. So when we multiply the two brackets, we will multiply every term from first bracket to every term on the second bracket. So we don't have to actually multiply each of the terms. We have to just observe which ones give us a constant. Now let us start with the first term here, 9. 9 multiplied with 64 gives us a term independent of x, of course. So we will write 9 into 64. Then 9 with this x square terms will give us x square. 9 with x power 4 gives us x power 4 term. So if you go to any number of terms here, when you multiply with 9, it will all have a x term. So we will not get any independent of x term. Alright, so now let's go to the second term here. Minus 6 over x square. If you multiply it to 64, there is an x square term in the denominator. So that is not a term independent of x. How about this multiplying with this? There is x square in the denominator, there is x square in the numerator, which will cancel each other. That means that term will be an independent term of x. So we get plus this minus x multiplied with minus 48 will be the next term. So if you multiply this with the x power 4, there will be x square term. So no other terms will give. So the last thing is we will multiply this term. This 1 over x power 4 multiplied with 64, no, it gives an x power 4 term, x power 4 in the denominator. With this, no, there will be a balance x square term. Now when this multiplied with this, the x power 4 cancels out with x power 4, leaving us with 15. So that is one term which is independent of x. So it is 1 multiplied by 15. So simplifying this, we get 879. Let us start with question number 5. When e power y is plotted against x square, a straight line graph passing through the points 2.24, 5 and 4.74, 10 is obtained. Find y in terms of x. Alright, so let us look at the graph first. So it is given when e power y is plotted against, that means that is on the y axis and x square is on the x axis. So this is the graph. This is the Cartesian plane. The graph may be like this. So e power y plotted against x square, a straight line graph is obtained passing through 2 points. Okay, so the 2 points, one may be here and one may be here. They need not be accurate, but drawing of such a thing will help you understand the question better. So always have a small drawing by in one corner of your paper, which will help you a lot. Okay, so the moment we see it is a straight line, we can write the equation of this one. So we know the equation of a straight line is y is equal to mx plus c, right? Now we have to see what is on y axis, e power y. So here instead of y we have to write e power y, whatever is there on the y axis, equal to m into x means x square plus c. Now we have to find m. and we have to find C. For that, we will make use of the 2 points. One for the first point, 2.24 and 5. So that means the value of y is 5. So replace it as 5 equal to m into the entire x square. That means the value of the x axis, which is 2.24. So students, please understand, you are not going to write e power 5 or 2.2 power x 2.24 powers 2. You don't have to, you will not write like that. It is a wrong method. It is e power y entirely is represented on the y axis. So the y coordinate will replace this entire thing. Similarly, the x coordinate value will replace this entire x square thing. So make sure you don't do the mistake of raising this to the power of e or squaring this term. Alright, so this is our equation number 1. Using the second point, we get a second equation. The y value is 10 equal to m into 4.74 plus c. This is equation number 2. So these are the two simultaneous equations. We can solve them. So we can do 1 minus 2. When we do 1 minus 2, the second equation sign will change. So plus c minus c cancel. 5 minus 10 we get minus 5, and m into 2.24 minus 4.74 will give us 2.5. Minus 2.5 because the bigger number sign is minus here. So from here we get m is equal to 5 over 2.5, which is 2. Now from equation 1, we will substitute this m value to find c. 5 equal to 2 into 2.24 plus c, which is 4.48 plus c. So c is 5 minus 4.48, and that gives us 0.52. So we found the value of m, we found the value of c. So our equation of the straight line is ready. So equation of our straight line is e power y is equal to m. M is 2 x, mx. X means x square plus c. C is 0.52. So this is the equation of the graph. Now the solution is not complete yet. We have to find y in terms of x. How do we do that? So to get y in terms of x, we have to apply log. Okay, taking log on both sides of the equation, what we get? Log of the natural log. Okay, taking natural log. So it is, we write ln, natural log, because whenever the power or the base is e, whenever the base is e, we say it is a natural log. So ln e power y is equal to ln 2x square plus 0.52. So going by the definition of ln, what is ln e power y? Ln a power b can be written as b ln a, right? So going with that, the index comes first, multiplied with ln e is equal to ln 2x square plus 0.52. Now what is ln e? Similarly, ln e to the base e is 1. So y is equal to ln 2x square plus 0.52. So this is the answer for question number 5. Question number 6. The diagram shows a circle, center O and radius 2a. The points A and B lie on the circumference of the circle. The points C and D are the midpoints of the lines OB and OA respectively. The arc DC is a part of the circle center O. The chord AB is of length 2a. Find the angle AOB, giving your answer in radians in terms of pi by 3. Okay, so we have to give the angle AOB. Look at the triangle AOB. You will find that this triangle is an equilateral triangle. Why? AB is given as 2a. OB, you can see it is 2a also, and same as OA, because OB and OA are radii and radius in a circle is same. So we see that all three sides of a triangle are same, and hence this is a equilateral triangle. So in an equilateral triangle, all the three angles are same. So it is 180 divided by 3 is 60 degrees. So 60 degrees we have to give in radians, it is pi by 3. So this angle is pi by 3. So answer for A is angle AOB is equal to pi by 3 radians. Question B. Find in terms of A and pi the perimeter of the shaded region A, B, C, D. Okay, so this is A, B, C, D. This is D, C, this. So we have to find the perimeter, that is the length of this plus this one and the arc length here. So we know all the three lengths. This is A, and this is 2A. But arc length is not known, so we will find that first. So arc length DC is equal to, the formula is R into theta. Since we are dealing with radians, the formula is R into theta. So for this arc length, the center is here O and the radius is A, and this angle is pi by 3. So we will substitute A into pi by 3. So this is A pi by 3. Therefore, the perimeter of this shaded area is 2A plus 1A plus the other A plus the arc length, A pi by 3. So this simplifies to 2A, 3A, 4A plus A pi by 3. So this is the answer for 6B. 6C. Find in terms of A and pi the area of the shaded region A, B, C, D. Okay, so the area of the shaded region we get, so this is O, this is A, B and D and C. So to get this shaded area, we have to get the triangle AOB area first, the entire triangle AOB area, and from there if you subtract the sector area, sector DOC area, we get shaded area. Okay, so I'm just repeating, from this entire big triangle area, you remove this white area, we get this shaded area. Let us calculate the areas one by one. So let us write shaded area is equal to the triangle AOB area. So what is the formula for area of a triangle? We know two formulae. That is, one is half base into height, and the second one is the trigonometric formula, which is half AB sine C. So A and B are the two sides, any two sides of the triangle, and C is the angle included by the two sides. Now we know this angle as pi by 3. So the sides we select will be OA and OB. So this area becomes half into A, which is 2A, into B is the another side OB, which is also 2A, into sine of pi by 3. That is the area of the triangle AOB, minus the area of the sector ODC. So the formula for sector area is r square theta by 2. So it is half into r square. So for this sector, the radius is only so much, which is a. So it is a square into the angle, which is pi by 3. So this 2 cancels with 2 here. We have 2a square into sine pi by 3 is sine 60, which is root 3 by 2, minus, we don't have any terms cancelling here, so we will write it as pi a square divided by 6. So we can simplify this as a square, which is the common factor. The 2 and this 2 cancel, so root 3 minus pi by 6. So you can leave the answer in this format. So this is the answer for 6C.
Thank you for being there in my classroom today. If you need any clarifications on any of the questions that we solved today, you may contact me on my channel in Discord. For more details, please refer to the description box below. Thank you.